Hello everyone. Today we are going to continue with the types of molecular velocities. Okay, so already we have started discussion of types of molecular velocities, right now. So how many types of molecular velocities totally? There are three types of molecular velocities. Three types of molecular velocities. Among those, what? RMS velocity, most probable velocity, and next what? Average velocity. So three types of velocities we have. So yesterday we have discussed about this fraction of molecules versus molecular speeds. Fraction of molecules versus molecular speeds graph if you take. In this we get what now here? At low temperature we get narrow curve, and at high temperature we get the curve with flat peak, broadened peak. The wider peak will be there at high temperature, and narrow peak will be there at low temperature. So this point you keep in mind. So it is about this one. Now at every temperature, how many types of velocities will be there? Three types. So here like this here. So it is another type of velocity. So first one, this one is what now at the highest point of this peak. From this point, if you take, this is what now here most probable velocity, UMPTs. And this point is what now here, from this another point, from this point we have taken. So from this point, this is what now here average velocity, U average, you take it U average. Okay, so average velocity. After this, here at this point, another point I'm taking on the same curve. Let it be, it is URMS. URMS means RMS velocity. So RMS velocity, average velocity, and most probable velocity. At every temperature, three types of velocities will be there. At T1 temperature, three types of velocities like this. Among these, which is having more magnitude, I told you, RMS velocity has more magnitude. Least magnitude for most probable velocity. And most number of molecules, the most fraction of, means for very large fraction of molecules will be having what now here? This, what here? Which velocity? It will be having what now here? So most of the molecules will be possessing what? This most probable velocity. So large fraction of molecules, very large number of molecules will be having what? The velocity called most probable velocity. So that we have discussed already. So next, now the same thing what we have discussed is this one here. Suppose we are taking here nitrogen gas. Which gas we are taking? Nitrogen gas. For this nitrogen gas, how many types of temperature we have taken? Different temperatures. First at low temperature, 100 Kelvin, and 200 Kelvin, 300 Kelvin, 500, 700, 1000. That means when we are increasing the temperature of this nitrogen gas, what is happening for the same gas at different temperatures? So what is the graph here? For same gas at different temperatures. Okay, ma. So which one is having a narrow distribution of molecular speeds? At 1000 Kelvin, at 100 Kelvin, sorry, at 100 Kelvin, whatever the curve obtained, that is what now here narrow curve. That means what narrow peak is there. The peak is narrow. So the narrow peak is available in which case here? 100 Kelvin. Okay, ma? So when increased temperature from 100 to 200, what happened here? The peak became what now here? Somewhat flat. The peak of the curve became what? Somewhat flat. Here it is narrow, sharp peak is there here, right now. So here broader it became. So like this, when temperature increases, what happens? The the top of the peak means what? The peak becomes what? Somewhat flat. And what we can also say here, the total area under this curve of 100 Kelvin and the total area under the curve of 200 Kelvin, both will be same, remember. The area under curve of 100 Kelvin and the total area under the curve of 200 Kelvin. These two will be same. This total area under each curve represents what? The total number of gas molecules. The total number of gas molecules, right? So this point you keep in mind. So like this, what they'll give in examination: T1, T2, T3, T4, T5, T6 temperatures will be given. Which is highest temperature they ask. So this temperature will be highest here. For this curve, the temperature will be highest. Okay. Next, another type of graph we have taken for what different gases now here. See here, it is oxygen gas. Oxygen gas gram molecular mass, how much? Molecular mass is 32 gram per mole. 32 gram per mole is what now here? Gram molecular weight of oxygen. And what is gram molecular weight of nitrogen here? 28. 28 gram per mole. Okay, so like that here we have taken hydrogen gas. Hydrogen gram molecular weight, how much now here? 2 gram per mole. Right now. So 2 gram per mole is what now here? Gram molecular mass of hydrogen. Like this, when you take these different gases here, it is water vapor. Water vapor, how much? 18 grams per mole. So water vapor, helium gas, hydrogen gas. Now, in case of which gas here, in case of which gas, the peak is narrow here for oxygen. Here, narrow peak. What is my narrow peak is there? So narrow peak is in case of what? Heavier gas. So now here, what is heavier gas here? This one. So heavier gas here. Relatively, oxygen is heavier than remaining gases mentioned here. It is what now here? Lighter gas. Lighter gas. So lighter gas and heavier gas. In case of heavier gases, what will be observed here? The narrow peak is observed. Means the narrow distribution. Narrow distribution of what? Narrow distribution of molecular velocities here. Okay. And here it is what now here? Broader. For hydrogen lighter gas, it will be broader. The peak will be broader. The maxima will be broader. Wider maxima will be observed in case of lighter gases. So in examination, they'll give you X1, X2, X3, X4, X5 gases. Okay. Now, which gas is having more molecular mass? They ask you. So this X1 gas must be having more molecular mass because the narrow peak, narrow distribution of molecular speeds is there here. So here it is the graph of what? Fraction of molecules versus molecular speeds. For different gases at same temperature, remember. It is taken what now here? For what? Different gases. For different gases at what now? At what? At same temperature. And for different gases at same temperature it is. So for different gases at same temperature, we have taken what now here? We have taken what now? The plot. The plot of what versus what here? The plot of fraction of molecules versus what now? Fraction of molecules versus molecular speeds. Next. Now some example problems we are going to discuss. So in this, first example is that calculate the kinetic energy. Calculate what? Kinetic energy. Kinetic energy in joules. Joules means what? SI units. MKSC. Okay. So in joules, we have to calculate what now here? Kinetic energy. Kinetic energy of how many grams given here? Some mass is given here. Weight is given. So weight of the gas is given what now here? Given mass is 8 grams. And methane. So methane formula is what? CH4. Methane, CH4, mass gas. So what is gram molecular weight here? Gram molecular weight is 16 gram per mole. Okay, so 16 gram per mole is molecular mass of what now here? Methane. And what is the temperature mentioned here? 27 degrees Celsius. So now 27 degrees Celsius means what now? 300 Kelvin. 300 Kelvin. Why 300 Kelvin here? 27 degrees Celsius plus 273. It will be what now? 300 Kelvin. Right now. So it's about what now here the problem. So kinetic energy we are asked to calculate. Now see here first the solution. Number of gram moles. Gram moles means moles only. Number of gram moles nothing but number of moles. So number of moles of methane that is small n here. Number of moles given by small n is equal to given weight by gram molecular weight. So given weight is how much here? 8 grams and it is 16 grams. Okay, so 8 grams by 16 that is equal 1 by 2. 1 by 2 means 0.5 moles here. How many moles? 0.2 moles of 0.2 moles of which gas is taken here? Methane gas is taken. Okay. Next, temperature in Kelvin, how much now? Centigrade temperature given plus 273 will be equal to 300 Kelvin. And R value in joules, how much? 8.314. 8.314 round off taken as what? 8.32. 8.314 means 8.3 is enough. 8.3 is enough. 8.3 joules Kelvin inverse mole inverse. Okay. Next, the kinetic energy for 1 gram mole. For 1 gram mole means 1 mole. N is equal to 1 for 1 mole. For 1 gram mole meaning what? For 1 mole, the kinetic energy formula what? 3 by 2 RT. Actually, formula what? Kinetic energy formula for N moles? For N moles, 3 by 2 nRT. 3 by 2 nRT. So in this, N is what? Number of moles. How many moles we have taken? 1 mole. Na? That's why here 3 by 2 1 RT. So 3 by 2 RT. So 3 by 2, R value 8.314 joules, and T how much here in Kelvin? 300. So totally we get kinetic energy in what? Joules. The total value of kinetic energy will be in joules. Okay. Thus, kinetic energy for half gram mole means half mole. That means what? 0.5 moles. For 0.5 mole of gas, the kinetic energy is equal to half into this one, half into whatever we got here. So it is for 1 mole. Na? This is for 1 mole. So 1 mole, for 1 mole, how much more? 3 by 2, 8.3, 3 by 2 into 8.3 into 300. Right? Then for half mole, how much? For half mole, how much? For half mole. 1 mole is equal to 3 by 2 RT. Na? Then half mole is equal to how much? So 1 by 2 into 3 by 2. This way. 1 by 2 into 3 by 2 into 8.314 into 300. It will be what now here? 1872 joules. 1872 joules. Like this, what now? Kinetic energy for half gram mole is equal to 1872. Remember. For 1 mole, how much? It will be double. So it is about what now here? One of the important problems. And next example problem is here. Calculate the average and total kinetic energy. So average kinetic energy, average and kinetic energy total. Total kinetic energy and average kinetic energy, both they asked to find out here. Energy of 0.5 moles. So N is equal to what now? 0.5 moles. So 0.5 moles of gas is taken here, of ideal gas. So which gas they did not mention here? Which gas they did not mention? Simply they said that some ideal gas. And what is temperature mentioned here? 0 degrees Celsius. So what is absolute temperature here? Absolute Kelvin temperature, what? Centigrade temperature plus 273. So it is 0 plus 273. That is 273 Kelvin temperature is mentioned. Number of moles 0.5 moles, and total kinetic energy asked, and average kinetic energy asked here. Okay. Now here, average kinetic energy per molecule. Remember, whenever they ask you average kinetic energy, we have to take per molecule. For single molecule, we have to take. Total kinetic energy means per mole. Total kinetic energy means per mole. Generally, for n number of moles, it is total kinetic energy. But for one single molecule, the kinetic energy is called for generally average kinetic energy. Whenever they ask you average kinetic energy, we have to take average kinetic energy per single molecule. Is given by the formula 3 by 2 R by N T. So this R by N is nothing but, so 3 by 2 KT. This K is nothing but R by N. K is nothing but R by N. R is what? Your universal gas constant. Na? R is what now? Universal gas constant. So it is 8.314 joules, right? By N is what? Avogadro number here. N is what? Avogadro number. So Avogadro's number value how much? 6.023 into 10 power 23. Okay, so 23 per mole means mole inverse. Per mole we got this one. So here, what is the units here? Joules, Kelvin inverse, mole inverse. Joules, Kelvin inverse, mole inverse, right, ma'am? So 8.314 joules, Kelvin inverse, mole inverse. This is R value. And Na is what now? 6.023 into 10 power 23 particles per mole. 6.023 into 10 power 23 particles per mole. So this mole inverse get cancelled. So then what is the unit of this one? K. K is called what? Ratio of universal gas constant to Avogadro number. This is called Boltzmann constant. What is called, ma? Boltzmann constant. So Boltzmann constant K is equal to R by N. Boltzmann constant K is equal to what? R by N. Now 8 by 60 take roughly. 8 by 6. 8 by 8.3 by 6. It will be approximately 1.38. Into this 10 power 23 will be taken up. 10 power minus 23. Then joule Kelvin inverse. What will be the units of Boltzmann constant? Joule into Kelvin inverse. Means joule per Kelvin. Joule per Kelvin will be there. So 8.3 by 60 take. That is 1.38. 1.38 into 10 power minus 23 joule per Kelvin will be the value of what Boltzmann constant came. So like this here, what we have to take average kinetic energy formula what? 3 by 2 kT. Average kinetic energy formula what? 3 by 2 kT. K is what here? R by Na. R is what? 8.314 joules. Na is what I have got a number. That value will give Boltzmann constant. So if you substitute this value directly, we can get here. Okay. And one more thing, wherever R is there, 8.314 value is there now. That you take it as 25 by 3 for easy calculations. Okay, for easy cancellation in the calculation part, you can take 25 by 3. So 8.314, you take roughly as what? 25 by 3. So 25 by 3, if you write instead of R, it will be easy for calculations part. Okay, calculation you can do easy. That point you keep in mind. So here, when you substitute all the values here, 3 by 2, R value 8.314, and we have taken in ergs here. R value we have taken in ergs in this case. So here we got answer in ergs first. Then we convert into joules. Instead of getting in erg and converting into joules again, directly take values in joules only. Directly can take values in joules. Okay. So anything we can do. So directly we can get joules here. Okay. So like this, first we got ergs and then we got converted into joules. So what is the relation between erg and joule here again? 1 erg is equal to 10 power minus 7 joules. It is CGS unit. It is SI unit. 1 joule equals to 10 power 7x. 1 joule equals to 10 power 7 erg, right now? But here 1 erg is equal to 1 erg is equal to 10 power minus 7 joules. Like this, in place of erg, what we write here? 10 power minus 7 joules we wrote here. This calculation part everyone should do. Later you do all these calculations individually. Next, total kinetic energy now. Total kinetic energy, not average here. Total kinetic energy of 0.5 moles of gas. 0.5 moles means N is what now? 0.5. Number of moles how many? 0.5 moles given here. Now total kinetic energy formula what? 3 by 2 nRT. 3 by 2 nRT. So total kinetic energy formula what now? 3 by 2 nRT. N is what? Number of moles given here? 0.5 given. So number of moles given here, number of moles into RT. 3 by 2 nRT. So 3 by 2 nRT. Then we got joules. So if the answer is in ergs, if answer is given in ABCD options given in ergs, suppose. If answer is given erg, you have to take what? 8.314 into 10 power 7 ergs you have to take. R value. It is R value. Okay. So it's about what now here? The calculation of average kinetic energy. It is per molecule. It is per single molecule. And it is total kinetic energy. Okay. So here X we have taken. X we have to convert first into joules. Joules into kilojoules. If answer is given in kilojoules, suppose. If answer is in kilojoules, converts erg into joules first. Joules into kilojoules. Already we know that 1 erg is equal to what? 10 power minus 7 joules. And we also know that 10 power 3 joules equals to 1 kilojoule. 10 power 3 means kilo, na? 1000. So 10 power 3 joules equals to 1 kilojoule. Then x joules. Then x joules equals to how many kilojoules? Like this, we convert into kilojoules. 10 power 3, 1000 joules equals to 1 kilojoule. Then x joules equals to how many? So x into 1, x by 10 power 3 will be in kilojoules. So like that you can convert into kilojoules. Another example problem is that calculate the pressure. Calculate what? The pressure exerted by 10 power 23 gas molecules. So number of gas molecules here. Number of gas molecules. So how many gas molecules mentioned here? 10 power 23 molecules totally. Each of mass 10 power minus 22 grams. It is what now? Mass of each gas molecule. Mass of each gas molecule, how much is given, ma? 10 power minus 22 grams. And how many molecules of this one? 10 power 23 molecules like this. Now total weight, total mass will be equal to what now here? 10 power 23 into 10 power minus 22 grams, total mass. Okay, so in a container of volume 1 liter. So what is the volume given here? V is equal to 1 liter. Volume is given to you. Now what they asked to calculate here, and also they give the RMS velocity. RMS speed of the gas is given 10 power 5 centimeters per second given. Remember, centimeters per second means CGS or MKS given. CGS units they mentioned, and they asked to calculate what now? Pressure of the gas. P is equal to what? Now P we have to calculate number of gas molecules given to you, and mass of each gas molecule is given. Volume V is mentioned, and RMS velocity C is given. C means what here? RMS velocity. Instead of C, what we can also use here? U. U otherwise C, RMS velocity. Now, using kinetic gas equation. Okay, which theory we discussed earlier? KMT. KMT means kinetic molecular theory of gases. From that, we have derived one equation called kinetic gas equation. PV is equal to 1 by 3 MNC square. 1 by 3 MNC square. So here P is asked to calculate. V is given, mass of each molecule given, number of gas molecules given, C, RMS velocity given. So now from this P is equal to what? 1 by 3 MNC square by V. Okay, this formula we have to apply. Now see, these units are very important. Formula everyone knows, but which value we have to substitute, that is very important to get the answer here. So given that V is equal to 1 liter, that is 1000 ml, that is equal to 1000 cc. 1 cc is equal to 1 cc is equal to 1 centimeter cube, na? That is equal to 1 ml. Okay, ma. So here 1000 ml equals to 1000 cc. Is it clear? Next, number of gas molecules, how many? 10 power 23. And mass of each gas molecule given grams in 10 power minus 22 grams. It is CGS or MKS unit mentioned? CGS. So mass is in CGS. Okay. Next. And what here? C. C is what? RMS velocity here. What is C here? RMS velocity. So RMS velocity given how much here? 10 power 5 centimeters per second given. Right now. Here also what is given? CGS. Always remember the units you have to round off, and you have to check whether MKS unit or CGS unit. First you have to do this one. Otherwise you will make mistakes, I'm telling. Please always underline the units and confirm whether CGS unit is given or MKS unit is given. What we have to substitute in the formula, we have to understand. All these values should be in either CGS unit or in MKS unit. Any one type of units only we have to mention here. That's why you have to write always what now? Type of units here. Next, substituting the values in the above equation. P is equal to 1 by 3. Here it is what M, mass of each gas molecule, M, mass, and number of gas molecules, how many? 10 power 23. And also what now here? C square. C is given what? 10 power 5 now? 10 power 5 whole square what? 10 power 10. It is C square. And what is given volume here? 1000 cc. 1000 centimeter cube. Centimeter cube is what now here? CGS unit of volume. CGS unit of volume is what? Centimeter cube. That's why we have taken volume in centimeter cube. Okay, 1000 cc we have taken. So all we have taken in what? CGS only. All units are in. All are CGS units. We have used what now here? CGS units. Therefore, this pressure also will be obtained in which units now? CGS units. Generally, pressure formula what? Pressure is equal to force by area, no? Force by area. So force is what now in dyne? CGS units, dyne. Area what now? Centimeter square. Okay, so dyne per centimeter square. So the pressure we get in dynes per centimeter square. Right, ma? So we got 3.33 into 10 power 7 dynes per centimeter square. So this is the final answer you have to get once again. Once again, do calculation on your own and get this answer, final answer, and confirm. Okay. The next, another important problem is that calculate the root mean square speed, RMS speed we have to find out, of oxygen molecule. Oxygen molecule means O or O2. O2 we have to take oxygen molecule. What is the gram molecular mass here? GMW, gram molecular weight, how much? 32 gram per mole. 32 gram per mole is what? Now gram molecular weight of what? Oxygen molecule. And what is temperature mentioned here? Capital T is what? 288 Kelvin. Already in Kelvin temperature they mentioned. So need not to convert again. So already Kelvin temperature is given. And they asked to calculate this RMS velocity in what? SI units. In SI units we have to get. So RMS speed. Speed means generally what? Speed means what? Meter per second. Na? In meter per second we have to use. SI unit is what? Meter per second. In meter per second we have to get. Okay. For that we need to substitute all the values in SI units. Na? R value in SI unit. Mass in SI unit. All should be in SI units. Remember. Now see. The formula for RMS velocity what? So URMS. URMS will also be taken as what? C. Okay. So C is equal under root 3RT by M. Okay. So R value how much? 8.314 kilopascal. In place of kilopascal, we can write 1 joule. In place of kilopascal, we can write joule. 1 joule is equal 1 kilopascal. Remember, 1 joule equals to 1 kilopascal. Kilo means what again? 1000, 10 power 3 pascal. So kilopascal. 1 kilopascal equals to what now? 1 joule. Remember. So R is equal to 8.314 kilopascal, that is joule, into decimeter cube. Decimeter cube means for liter only. Decimeter cube means for liter. 1 decimeter cube is equal to what? 1 decimeter cube is equal to 1 liter. 1 centimeter cube is equal to 1 ml. 1 milliliter. 1 decimeter cube, 1 liter. So here decimeter cube means liter only. So joules, okay, means what here? Kilopascal into liter. Kilopascal into decimeter cube. This will be equal to joules. This together will be taken what? Joules. So instead of writing R is equal to 8.314 joules, we can also write what now here? 8.314 joules Kelvin inverse mole inverse. Otherwise, 8.314 kilopascal into decimeter cube. Kilopascal into decimeter cube. So what we have to take here? 1 joule equals to kilopascal into decimeter cube. 1 joule equals to what, ma? Kilopascal into decimeter cube. In place of kilopascal into decimeter cube, what we can take? 1 joule we can take. So 1 kilo means 10 power 3 pascal into decimeter cube. Decimeter cube nothing but what? 1 liter only. Remember. Next. And now what is the absolute temperature mentioned here in the problem? 288 Kelvin. Okay. And M is what now? Molecular mass. Gram molecular weight. This gram molecular weight, generally we know in grams. Na? What is the value in grams here? 32 grams here, oxygen. Now 32 grams, how to convert into kilograms? So gram molecular weight of O2 is equal to 32 gram mole inverse. So in place of gram, we have to substitute. We have to write in MKS unit. Na? So kilograms. So 32 into 10 power minus 3 kilograms per mole. Okay, ma. So here 1 gram is equal to 10 power minus 3 kilograms. Right, ma? 1 kilogram is equal to 1000 grams, but 1 gram is equal to 10 power minus 3 kilograms. 1 by 1000. Like that here, in place of gram, what we have written? In place of gram, what we have to write? We have to write what? 10 power minus 3 kilograms. So 32 into 10 power minus 3. That is what now? 0.32 kilograms per mole. The same thing, how we have written 32 into 10 power minus 3. That only we got this one, 0.032 kilograms. Right, man? So this point keep in mind. Substitute the values in the above equation. C is equal to what now? Under root 3 RT by M, no? 3, it is R. R value in joules we have taken. T, temperature, RT, 3 RT. And it is M, molecular mass. Gram molecular mass in kilograms we have taken. If you take 32 here, answer will be wrong. Remember, here 32 we should not take. 32 grams we should not take. The 32 grams should be converted to kilograms. Then only we'll get answer correctly. Remember. So the C value, RMS velocity is equal to what? 473.79 meter per second. Again, this final answer you have to get later. Today only you do all these problems. I'll send you PPT today compulsorily. Please, if I forget also, anybody remind me in the WhatsApp. I will send you. Okay. So please do all the problems. Final answer you have to do it. You have to get on your own. Next is that calculate the root mean square speed. Calculate the root mean square speed of hydrogen molecule at STP. So what is asked here? RMS velocity asked here. So RMS velocity is equal to what? Okay, for which molecules they asked here? Hydrogen. So hydrogen molecule means H or H2? H2. For H2, what is gram molecular weight? 2 grams per mole. 2 grams per mole. So in these problems generally, 2 grams must be converted to kilograms because MKS system we have taken. So that's why 2 into 10 power minus 3 kilograms we have taken. Grams we should not take directly here. Kilograms we have to take MKS unit. Okay. So then STP they are mentioned here. STP means what is temperature? 273 Kelvin. STP means what? 273 Kelvin. And at STP, 1 mole of any gas, 1 mole gas is equal how many liters? 22.4 liters. This one always we have to recall whenever STP is mentioned. Now what is the formula of this one? RMS velocity formula, tell me. There are different types of velocities now. In that, RMS velocity, CR, URMS, anyone we can use. So first formula is what? 3 RT by M we know. Next, in place of RT we can add PV now, because PV is equal to RT for 1 mole. PV is equal to RT for how many moles? 1 mole. For 1 mole of gas, what will be taken? PV is equal to RT. In place of RT, what we can write? In place of RT, PV we can write. So 3 PV by M also we can write. And also one more formula what we can write from this? Now volume by mass. Volume by mass means 1 by density. So what we can write this one? Under root 3P by D. D is what now? Density. D is equal to what here? Volume by mass by volume. Mass by volume. And volume by mass is equal to 1 by D. So that volume by mass is equal to 1 by D we got. So RMS velocity 3 formula we have to recall always. RMS velocity formula what? Under root 3 RT by M or under root 3 PV by M. Otherwise, under root 3P by D. Density. P is pressure, D is density here. So now which formula we have to use here? This one. This one we have to use. Okay. So now C is equal to under root 3 PV by M. We can also take RT. This formula both can be used here. This formula we cannot use here. Why? Density is not mentioned. This formula we cannot use. These two we can use. Now see here. C is equal to under root 3 PV by M and P is equal to 1 atm generally at STP. It is what now at STP. STP pressure is what now? 1 atm. So here 101.3 kilopascal. Okay. So 1 atm is equal to how many kilopascal? 101.3 kilopascal. Remember. Next, V is equal to 22.4 liters. Liters here. Decimeter cube means liter only. 22.4 liters. Okay. Volume, because 1 mole of any gas at STP will occupy 22.4 liters. Next, molecular mass is 2 grams per mole. That is 0.02 kilograms per mole. Okay. Substituting these values in this formula, we get under root 3 RT. 3 PV, sorry, 3 PV by M. We got this one, 1844.9 meter per second. Okay, so it is the SI unit we got. We substitute all SI na. That's why we got SI here, meter per second. And alternative method, which formula we can also use? RT we can use in place of PV. So what here? C is equal to RMS velocity is equal to under root 3 RT by M also we can take 3 RT by M. So in this we substitute R value and T value. So 3 R in joules and T temperature by mass in kilograms. Okay, so like this we got what now here 1845. 1845 here, 1844 here. Nearly 44.9 means 45 only now. So here 45. So the nearly same answer we got. Okay, we can use what now here? Under root 3RT by M. Otherwise, under root 3RT by 3PV by M. And one more problem you see. Oxygen at 1 atmosphere. Oxygen gas means always what we have to take formula O2. And what is the gram molecular mass? 32 grams per mole. Otherwise, 32 into 10 power minus 3 kilograms per mole. Okay. Next, 1 atmosphere means pressure is given here. Pressure is given 1 atmosphere. And 0 degrees Celsius, capital T temperature is 273 Kelvin. Has a density given here, density of this one, D. So density mentioned in what? Gram per liter. So for gases, the density units will be gram per liter. Find the RMS speed. Find the RMS speed. RMS speed means URMS they ask here. For which molecule they ask here? Oxygen. For oxygen, RMS speed is asked here. So URMS of oxygen asked here. Okay. Now pressure P is equal to 1 atm they mentioned. 1 atm means how many Pascal? 101.3 into 10 power 3 Pascal. So Pascal is what now? SI, unit of pressure. SI unit of pressure is what now? Pascal. So we converted 1 atmosphere into Pascals here. 1 atmosphere, how many Pascals? 101.3 into 10 power 3 Pascal. That is 101.3. 101.3 kilopascals. Already we discussed it. Kilo means 10 power 3, na? Like this. Next, density is given here. Gram per liter they mention C, but we have to convert into kilogram per meter cube. SI unit of density. SI unit of what? Density. So SI unit of density is what? Kilogram per meter cube. So gram into kilogram, liter into meter cube. We have to convert. So 1 meter cube is equal to what? 10 power 3 liters. Remember, 1 meter cube is equal to 10 power 3 liters. So meter cube means 10 power minus 6 centimeters square. Okay, 10 power minus 6 centimeter cube. That is equal to 10 power 3 liters here. So 10 power 10 power 3 liters equals 1 meter cube. Then 1 liter is equal to 10 power minus 3 meter cube. We have to take. 1 liter is equal to 10 power minus 3 meter cube. We have to take. Okay, it is conversion factor here. This one.